I'm just giving you an example. It's not necessary how Google exactly does it, but gives you an idea of how they do a rollout strategy. When I was at Industrial Logic, the e-learning that we built, we had a similar strategy. So it would basically get rolled out to all employees of Industrial Logic. Then we would roll it out to Google, which was our biggest customer at that point. And if people at Google did not complain about a new feature that we put in, then we are good to go. We'll push it out to everybody else in the world, right? So that was our deployment strategy. Different companies have different deployment strategies, and this has frankly become a dream for every company today, where they want to get to continuous deployment, where they want to ship their product multiple times a day, right? It doesn't have to be a web-based thing. It can be anything. Chrome is not a web-based thing. Chrome is a desktop client, right, that you're using on your phones, on your laptops, on your iPads, wherever you're using. So, you know, it is something that now every company is aspiring to have continuous deployment. But the problem is, what is the problem? Everyone wants to do continuous deployment. That's a dream. But how many companies actually practice continuous deployment? Can anyone put up a hands? How many of you here are practicing continuous deployment? What is stopping you guys? So what I want you to do is now form a small group at your tables and come up with top 5 reasons why you think this cannot be done on your specific projects or in your companies or projects you've worked with. Right? So do groups and then discuss. You have 5 minutes, then you have to, each table is going to tell 5 points. First of all, do you think this is desirable? This is good as a concept? Do you think it's a good concept that you should be able to deploy into production any point in time? Every time a developer checks in, you should be able to deploy. What's the advantage? Very quick feedback. Ability to break down your product and release in very small chunks to the product so the impact is controlled. Right? If I put 5 big features one shot, if any one has an issue, what do I have to do? Roll back all 5 features, right? One release goes in or it does not go. But with this, I can basically give very small chunks of things. More importantly, right, I can build a very micro version of the feature, right? A minimum viable version of the feature, a thin slice of the feature, put it out, see how many people actually like it, and then invest more on it. I can incrementally build it, right? If I don't have this mechanism, then I have to build the whole thing and put it out there, right? So that means in a lot of cases I might be building features that nobody wants. This helps you stop a lot of that, right? So there are a lot of different advantages. We'll talk about that in some time. But what is the challenge to getting to here, right? That's what I want you to discuss at your tables. Are most people belonging to the same company sitting at the same table? You're not going to learn much, right? Because all frogs in the same pond don't learn much. It's good to, you come to a conference because you can get to meet to other people and see their perspective. So not for this talk, but in future try and sit at different tables so you learn from different people, right? If all of you sitting, you're same talking about your own company's problem, you don't see how somebody else is doing it. Done? Top 5 reasons why you cannot do continuous deployments. We will start with this table over here. What are your top 5 reasons? You need to be loud so everyone can hear. Resources. What kind of resources? Manpower, time. Why do you need them? So to test this, you will need a lot of manpower, right? Anytime a developer checks in, you need a lot of manpower to test it, or rather to check it, right? So that's your top reason. All right, we'll go there. What's your top reason? Because your current development practices have a lot of stages, so you need to go through all those stages like design, commit, review, again another review, another God's approval, before you can actually push something into production, right? Architect's approval, someone else's approval from on-site. We'll go there. What is your top reason? Infrastructure. What kind of infrastructure? Buildings and roads and railways? Server infrastructure. For doing? Basically for running your continuous integration server and then running all the tests and your production like environment and things like that. And the client commitment. Tell me a little bit more about it.
Client should agree that should go to the live server.
Okay. For that you need to show results, right? Because if you tell me I'm going to push it to deployment, I'm like, no. First, I need to be convinced, right? For that, you need to show results. So that is something we can deal with, but infrastructure is a good problem, right? That needs to be addressed. We'll come here. Anything else other than what these guys have said? Google and Amazon all have really crappy brand image, right? Because they deploy so many times, like lousy guys. They can't just do once in a month. So if you fail, then that will reduce your brand image. But if you fail big once, then it's okay. Okay, so he's saying basically they have these different environments that they have at the client side, and it needs to go through these environments, and if they cannot short circuit and go straight to production. So you need to conform to all these different environments that you need to go through, and only then put it into production. Okay, we'll go there.
Knowledge barrier, say for example, like if you automate the process, so there can be a barrier.
So the automation of the whole build and deployment process for different segments of your customer needs to be in place for this to work. That's the biggest barrier you see. Okay, cool. Next.
In our case, it's the licensor and then maintainer. So if we give for free, like every day, I can report work once.
Okay. Can you think of any company which asks you to pay for licenses and still does continuous delivery, continuous deployment? Where you pay and buy a license, but they deploy things continuously to you. Microsoft has started doing it. Microsoft has started doing it, especially on their Office, the online version of their Office. They've also started doing it for their operating system. Mac OS, they don't do it as frequently, but they do send in these patches every now and then. With the whole App Store, have you guys heard of the whole App Store, the iOS App Store and other app stores? There people are practicing where you do buy stuff, right? But they do this thing, there are subscription based apps which people do subscribe, but then you keep putting stuff out there, latest and greatest version. So it is, you're right that that it is a different marketing strategy than what traditionally companies are used to. But there are enough companies out there who are doing it for paid products as well. It's just that how you position yourself, right? What will get the confidence? Like a couple of groups talked about customer does not have confidence. We have to go through all the different stages. What will get them the confidence? To see the benefits. But seeing the benefits will not give me the confidence, right? Seeing it in action is what is going to give me confidence. Google is doing it and I see the benefits. But that does not give me confidence. What will give me confidence is to actually see on my project this thing in action. Right? That's what will give me confidence. So one of the biggest issues that we see people face is what we refer to as, and few people did mention that, is what we refer to as the inverted testing pyramid problem or the ice cream cone problem. Everyone's familiar with this? Very little effort on unit testing, a lot of effort on end-to-end testing, and a very huge effort on manual checking. If you're stuck with this, there is no way you can do continuous deployment. Right? If you're stuck with this kind of testing model or this kind of a testing strategy, there is no way you can actually get to continuous deployment, because the effort it takes to do this is going to be huge, and you can't keep doing this for every small change that you make, right? Because I have to run the regression, and running the regression takes 3 weeks. Manually running all my regression tests, if you work on a decent sized product, right, then it takes about 2 to 3 weeks. So for very small change, I'm not going to spend 2 to 3 weeks of doing manual testing. Then another small change, another 2 to 3 weeks. So this will not be practical if this is your model of testing. Right? Does it make sense? This is the single biggest reasons why companies cannot move to continuous deployment, because their testing strategy is fundamentally flawed. Why is the testing strategy fundamentally flawed? Let's look at an example from another industry. Do you guys know what this is? Power looms. Do you guys have power looms over here in Sri Lanka? I'm assuming, right? You manufacture silk and you manufacture other cloth, and all of that uses power looms. So let me tell you a little story about power looms, because I grew up, my parents had a business of selling silk, and I grew up in power loom area. This is my childhood days, right? Typically a person would have about 10 looms in a building, and in the morning they would set up all these looms, and they would let these looms run through the day, right? And then in the evening they would take all the cloth that is manufactured by these looms, and they would get these workers who would sit in front of each other, and they would start checking the cloth. They would be looking for missing threads, or extra threads, or insects woven, or different kinds of things, because these are defects in the cloth, and customers don't like that. So they would be checking for stuff like this, and they would be taking out cloth which had these kind of defects, right? On an average, they found about 30% of the cloth defective, right? Sounds familiar? So what would happen to an industry which only has about 20% profit margin and 30% wastage because of defects? What would happen? Tough luck, right? Which is what happened to the massive industry in India. Today, India imports maximum of its silk from China and Japan. It's not manufactured in India. Majority of the silk in India comes from China and Japan. But obviously these guys are smart. I mean, they are not that stupid that if 30% loss, 20% profit, they will do something smart. Why am I talking about this in a software conference? Just because I grew up in power looms does not mean I should talk about it, right? Can you relate this to software? What happens in software? People write code which is like producing this cloth, and then you get a bunch of testers who come at the end, and then they start checking, and then they find all these defects, right? And then you have to fix it again. Right? It's kind of similar. What's the profit margins and how much percentage of losses do we make because of all the rework? Quite high, right? Luckily, software margins are much higher than the impact, so somehow the industry is surviving, but only barely surviving. More and more companies, at least in India, are telling us that they are firing all their testers. They cannot maintain that. It is not an economical model. Their customers are pushing them. So a lot of issues are happening in the software industry, at least in India and a bunch of other places. So what did these guys do in the loom industry? They are smart guys, right? So what did they do? They adopted the Scrum model. What is the Scrum model? You add 1 or 2 testers on the team. In this case, what they did, so if you have 10 looms, they basically got these people who would come at the end of the day, and then they started putting them on each looms, right? So as soon as a defect is occurring, they'll stop the loom, they'll fix the defect and let it run. This way the cloth is not defective. They catch issues at the source. What do you think is the problem with this model? You think this model worked really well? Production slowed down. Why did the production slow down? You stop every time. The production went down because not you stop every time, because now this guy has to go to eat lunch. This guy has to go to the bathroom, right? What will this person do? Let the loom run or stop the loom? If you let the loom run, chances of something slipping by is there. If you stop, then production takes a hit. It's 15 minutes from when? From 3 o'clock? Because we only started this at about 3:20. So if you're going to tell me 4 o'clock it ends, that's cool with me, but I think that would basically become very short. All right? I think we'll go up till about 3:10. 4:10, sorry. Okay? So this was a problem, right? The production took a hit. And in spite of having these individual testers or individual people on the machine, do you think they never needed any more else to do checking at the end? They still needed someone to do a second round of check to make sure something doesn't slip by, because the cost of that is very high, right? Or reputation cost. So they ended up actually spending more on the money and taking a production hit, which is what a lot of teams are doing with Scrum, which is absolutely stupid, right? Trying to put testers on the team and trying to catch issues at the source. That model, let me tell you, does not work, right? It's proven in other industry it does not work. You can experience it yourself, it does not work. What works? What with China and Japan doing that they export a huge amount of silk, and what was India doing wrong that we imported a huge amount of silk from them, right? Because we were trying to apply Scrum and that didn't work. What were these guys doing? You know of this company Toyota, right, which manufactures cars? You know, before it was manufacturing cars, what was it that company doing? It was manufacturing looms. That's where they come from. 90% of the practices in the lean production system actually comes from Toyota, not Toyota, but Toyota, which is their loom manufacturing. And one of the first things they did is they looked at, okay, what is the biggest reason for defects in cloth? And they found the biggest reason for defect in cloth is because of the tension. As the thread is spinning and going into the loom, because of the tension, the threads break, the threads snap, and that introduces defects into the cloth, right? So what did they do? They didn't say, let's throw more people at this. They said, that's not going to scale, that's not going to work, that's going to have other implications. Instead, they said, we're going to put these small levers on each thread that goes up. As soon as the thread breaks, the lever will go jam the machine, right? A very simple, stupid idea, which is obviously patented by them, so you can't use it. But they put small levers on each thread, and as soon as the thread breaks, it goes jams the machine. Right? They did a lot of other innovations which led them to be extremely superior, like automatically changing, having double threads, doing all kinds of interesting things. But the point I'm trying to make is their focus was not let's throw more people at it. Their focus was let's change the manufacturing process so quality is built into the process. It's mistake proofed, right? You mistake proof the process rather than throw inspection on it. So lean, a lot of people will talk about inspection is wasteful, because in fact inspection can only find out something went wrong after it has gone wrong, which means now there's a lot of rework, right? While the whole philosophy of lean, or in my opinion the original philosophy of Agile, which was mostly extreme programming, was to mistake proof the process so that things don't get in the first place, right? So what are the examples that you can think of where you're mistake proofing things, where you're stopping things from even getting in the first place? Adding a tester onto the team? Not really. What else can you do to stop things from getting in the first place? Mistake proofing the process or building quality into the process. We talked about continuous integration, right? Can you see how continuous integration is a mistake proofing mechanism? You stop something from getting in the first place, right? As soon as something is broken, you stop it right then and there. And if people are doing it so frequently, the chances of you having to do merges or you having to do any of those things almost disappear. Doing continuous deployment takes it to the next level, which means that now I can iterate on from ideation to production in a very short cycle. Not just from story to sprint, but from ideation to production I can go very quickly. So I can actually mistake proof that whole cycle. Test driven development, we talked about that in the other room earlier today. Test driven development is another practice where you're trying to mistake proof. You're trying to stop things from getting in the first place. Right? These are various different practices that at least Xtreme Programming introduced to the world, which were kind of very similar to what lean manufacturing or the whole Toyota production system TPS was all about. So yeah, back to the inverted testing pyramid, right? This is the problem today we have. And can you see how this model is based on the wrong fundamentals of testing? Why I was saying, this is still very heavy on inspection. And not building quality into the process, right? So this is why I was saying earlier that this is actually fundamentally broken, and what you actually need is what we refer to as the inverted testing pyramid. This is kind of what companies need today in order to be able to do continuous deployment, in order to build quality into the process, in order to mistake proof things at the source. This is a fairly intense diagram. We're going to come to this in a minute. But let's talk about where did I get this idea of inverting the testing pyramid? Where does the name come from? Anyone's read the book Inverting the Pyramid? Not the Egyptian pyramid. That's going to be crazy. I met a bunch of people when I was down in the south. People here like two sports, they said. One is cricket, Sachin Tendulkar, and the other is football or soccer. Right? Is that correct? Do you guys play soccer or football over here? No, only cricket. This is a book called Inverting the Pyramid, The History of Football Tactics. In this book, the author describes about how over the years the tactics of playing football, the strategies of playing football have changed, right? So Europe, which was very popular, they used to win all the World Cup, football World Cup. Their structure of the team, the football team used to be very heavy on the forwards, very next level was the midfielders and very few defenders, right? So this is kind of a pyramid. Very heavy forwards, few midfielders, very few defenders and one goalkeeper, and this is kind of their model of how they used to run. Until the Brazilian teams or the South American teams came about and started thrashing them left, right and center, match after match they started losing. And what were they doing differently, right? So someone actually went and studied the whole thing and they said, well, if you look at the structure of these teams, it's actually the opposite. So they have very few forwards, they have a good number of midfielders, they have a very strong defense. It was obviously in a direct, matching with what the opposition teams had. But this was kind of the strategy of how they used to have football teams. And there are like a lot of interesting strategies and details if you go into it. At a very high level, it talks about how over the years the pyramid is inverted in the testing, in the football teams. That's where I got the name or the idea of inverting the testing pyramid. If you look at a typical N-tier application, right, this is a typical N-tier application, talks to the database. If I were to write end-to-end tests for this, right, manual tests are typically end-to-end tests. If I were to write manual end-to-end tests, how many tests would I need to make sure that I have covered every single possible path through this mess? That's going to be a lot more because it's going to be it's going to be basically the number of nodes multiplied by the number of paths. That's the number of tests that I will need, which is in this case about 70 complex fragile end-to-end tests, right? Why are they complex? Because you need this whole thing set up, right? You need to make sure the database is set up. You need to have all of these things wired together with their dependencies, everything set up correctly for this to work. If one small change, a bunch of tests fail, right? Which is why they are fragile. right? So they're fragile, they're complex, and they're very time consuming. Running each of these tests take a lot of time. While instead, if you focused more on the unit test and very few end-to-end tests, right, then that would be a lot faster, that would be a lot more pinpointed feedback when something went wrong, and a lot of other advantages that comes with it. So if you look at a typical kind of a structure like this, you will realize that that unit tests, you get the impact you achieve is 90% with about 10% effort. As you move up the layers, the impact that you have with the investment that you make keeps reducing, the ROI keeps reducing on that. So the highest benefit you get is from unit tests. The least benefit you get is from the end-to-end tests. And the effort highest is spent on end-to-end tests, and so it's inversely proportional. One is reducing, another is increasing. Which is where basically we recommend that companies or teams should have this kind of testing pyramid. Now if you have a small single team agile project, then you can just have 3 levels: unit test, acceptance test, and GUI tests, right? If you have a large multi-site product which you are building and it's very complex, then you will have multiple layers of your tests, and they all kind of fit into this model, starting with unit test at the bottom of the pyramid and moving up to your business logic acceptance test, integration test, workflow test, end-to-end test, but more of a workflow test, one level below the UI, and then finally the UI or API tests, right? So this is kind of different levels. And if you notice here, it basically talks about what is the kind of coverage, additional coverage that you get, and how much investment you would want to make. So this is really the solid foundation of your testing pyramid, where you want to focus maximum energy on, right? The question is that if we have this inverted testing pyramid, how do we get to this, which is the desirable pyramid? What are the kind of things that you will need to make that transition? I mean, we are running short of time. I'm not going to go into details of this. I had slides which would explain the different kinds of unit tests, different kinds of tests, what are their purpose, what is intended, what kind of tools, objective, all of that stuff. These slides are already available online. You can read them. So I'm not going to go into details of them. It also talks about touch points of this whole thing in the cycle, right? Starting from your product discovery all the way to the release, what are the different touch points and how it works. There's also later talk about how you set up a continuous integration pipeline and why that continuous integration pipeline will help you deploy stuff such that it goes through the different stages that you guys talked about, but it doesn't short circuit that, but it goes much faster and it's automated and all of that stuff. All right. So I want to focus more on what are the 3 things, what are the 3 key things that you need to do starting yesterday that will help you get to this inverted testing pyramid if you believe that this inverted testing pyramid is the right pyramid, right? This pyramid that we have is how your testing should look on your project, right? So what are the 3 key things you need to focus on which will help you achieve this? Automation. Automation is a very broadly used term. I don't know what it means at this point also. It's like automation. Live healthy. What does that mean? You want to reduce the number of UI tests to start with, right? Focus more on the integration tests, unit tests. Do away with your manual testers. Tell them, refocus on things like, basically helping you mistake-proof things, helping you build much better tests in the first place, your acceptance test or things like that. But more specifically, I'm going to talk about 3 things. One is a practice called test-driven development or behavior-driven development, right? We already spoke about this in detail, so I'm not going to go into too much detail, but I'm going to quickly run through it. So we have stories, we have acceptance criteria, we write automated acceptance tests, those lead to automated unit tests, and then from there we have automated tests that work, which means that at this point when the developer says I'm done, the developers already verified all the different scenarios that the tester has. It doesn't have to now go to the tester and the tester has to verify. It's all built into the process. It's already there and the person can run it and make sure it's all working. Even before you say, okay, I'm done, let's, let the tester take a look at it. There's also what we talked earlier about exploratory testing, which is mistake proofing things, which are things that you might have not thought about when you're building the feature. And only when this is over, that's when you kind of go to your acceptance criteria or demo, and then from there your automated UI test and performance test and other kinds of things can be done at a later point. This is I'm just rushing through this, but this is kind of a quick practice that can really help making sure your focus in terms of the pyramid is right. You're focusing on the right things instead of focusing on the UI test too much. Right? The UI tests are very little here. The majority focuses on the unit test and on the acceptance tests. Right? This is one practice that I think you should really focus on. Read up more about this. There's a lot of material online available about how to practice automated acceptance tests. The second thing is what I call as the product discovery or the acceptance criteria driven product discovery. This again is a fairly elaborate process of things that are completely missing from Agile, things that people at Agile, inside the Agile, like especially Scrum, does not have any of these practices, and they're extremely critical. So we start right there with chartering, which is trying to define your business goals and stuff like that before we start building the product. And then we define personas, user goals. We do a day in life to try and understand what the personas are. What are the, when you write your stories, right, you write as that persona. So right, we kind of spend a good amount of time defining these personas. Then we do activity maps where we basically lay out what a typical flow of a user would be, how the user will interact with the system. Through that we do interaction design. I was showing a demo of interaction design and low fidelity prototype earlier in my talk. So all of those things are done to figure out what is my story map, what is my activity map. And then we, based on that, we do prioritization, regrouping, story authoring, and then you write user stories and acceptance criteria. So, a lot of people ask, where does user story come from, right? Does a product owner just sit and start writing Rama and Mahabharata? No, I mean, it comes with, a fairly rigorous process, which is a very collaborative process between all the people involved. I'm going to show you a quick picture of what I'm talking about. Right, this is an example of a story map. This is something where people have put down what are the different personas, what are the different goals they have, what are the different activities they would do to achieve those activities, what are the tasks, and then they have prioritized these into different buckets. So for example, it's not very easy to see. And then they have grouped them into different themes, and then they further deprioritize certain things, saying this is the thinnest slice, this is the most important thing, I want to focus on this, this is the next most important thing, we'll focus on this next. And these essentially become your incremental cycles in which you work, right? So when you start breaking down your product and visualizing your product in this fashion, working in a continuous deployment cycle becomes a lot easier because you know what the end goal is and how you're chasing it. This can keep evolving, requirements keep changing and stuff like that, but there is a way to visualize this and map it in your workspace so everyone knows what's going on, right? And the third practice, which is basically your continuous integration pipeline. I mean, continuous integration, most people think of continuous integration as something like this, right? Which basically has a version control, a continuous integration system, a test bed, some kind of a development environment, a whole bunch of tools that go with it. But here we are talking about doing more of a pipeline, not just a continuous integration server, but a whole pipeline starting with, all these different kinds of builds, each build having a different artifact, one build kicking off another build. So right from your local developer box all the way into production, everything is automated and have a whole structured orchestration of, once you check in, what are the different environments that kick in, how each environment validates what. This is stuff that has been worked by different teams, different companies have their own models of doing build pipeline, but this is kind of in general referred to as a build pipeline, right? This slide also talks about what are the different and builds, what is the objective of each build, what happens in each build, how much duration do ideally each of these builds take, what environment they run into. So it's a very dense slide. You can take this over a weekend and consume it. This is not for a quick talk at the conference. This is an example of a build pipeline where one thing kicks off another thing, that kicks off another thing, and then it shows how it's moving from one environment to another environment. There are also things like DevOps. Do you guys here have the concept of DevOps? Basically bridging the gap between developers and operations and kind of making, you know, that as one thing. So, you know, when you're talking about continuous deployment, you will need skills of automation, as in automating of your environments. You know, a lot of these Amazon and companies like that have made the thing very easy, so you can actually spring up a new you know, node on the fly. You can do, they have elasticity so it can expand, but a lot of that automation needs to be done, and that requires the operation skills. So there is a role called DevOps and a lot of agile projects that is, you know, getting prominence of basically bridging that gap between the two. So basically here we are talking about automation as in not the traditional sense of automation, but automating anything and everything that basically gets in the way of from the time you check in to the time it's actually deployed and you know, rolled out to the rest of your user base. Very important. But to get there, in my opinion, the three things are very which we discussed. One is the test driven development or behavior driven development, the other one is kind of doing this product discovery, and the third one is having this continuous build pipeline set up. Right? These are three kind of precursors to really being able to do continuous deployment, which in turn will help you invert your testing pyramid. All right. So that's a breeze through the talk without really going into too much details, but hopefully this gives you kind of a big picture of what we mean by inverting the testing pyramid, the incentives behind it, and some of the, you know, food for thought for you to take back from here and think about it. Any questions at this point? I don't imagine this being very different from anywhere in India. I mean, it should be very similar, right? Like if I go to France, I can expect people to be like really shy, and you know, you talk to someone at the conference, and you know, you're giving a talk, and everyone's sitting just like that, and then you go talk to them after the talk, and they say, "This was the funniest talk I've ever attended," and I'm like. But you were sitting so quiet. Oh, that's how, you know, we as a civilization are. But I would assume you guys are no different from what we have in India. So why are you guys so quiet? Are you afraid?
So, would you have any tools on how to automate these topics?
Adding the dimension of legacy, right, is very interesting, because now legacy systems don't have any tests, and for you to get to the stage where you get that confidence, it's going to take a much longer time, right? But the point is you need to start somewhere, because otherwise the legacy will continue being legacy and it will get worse day by day. It's not going to get better.
Sometimes the systems that I'm talking about might have been initiated in the 80s, 1970s or 60s.
Correct.
They're very old.
Yeah, I mean, I've worked on a product which was written in assembler. It is controlled inside a nuclear this thing, so nobody has access to it. That's what controls the world's airline, and that's written in assembler, right? So we actually did a lot of refactoring on that project, because, you know, that has to be maintainable, that has to scale. As the traffic load increases, deal with all of that stuff. The point is, it's not going to happen overnight. Right? It's going to take a while, because it took so many years to create the crap. It's not going to get cleaned up overnight. The advice I have, which I was already giving in my previous talk, is that anytime there is a requirement change, anytime there is a bug, anytime there is something that needs to be changed, you start with the test. Right? You write a failing test that forces you to make that change, and then you add that thing. And gradually over a period of time, at least the parts of the system where you're constantly changing, that will have a good coverage. In the meantime, you will continue to having all these manual tests which will keep getting translated slowly to automated tests. One is the test that developers would write before they make a change. Other is, you know, let's say there is a bunch of tests that I would need to run when I made this change, which are already there in Excel sheets or some kind of test cases. You try and automate those into these things. And gradually over a period of time, the unit test base will increase, the other test base will, you know, start coming up somewhere in the middle, and then you will have a few UI tests or things like that. So one is that approach, it will help you get there. Second is try and do a story map on it, right? Try and visualize what this system does, what are important, what is, you know, still relevant, what is still not relevant. When you make a change, what impact does it have? So having some kind of a story map will help you. And then even with the existing process, try and automate your deployment steps, right? Because I'm assuming that might not be 100% deployed, so automated, so try and slowly automate those steps. So gradually when you start approaching from all these three dimensions, your legacy will kind of